Hello, I'm back for another video where I'm going to look at the core API of TensorFlow.js. And in my introductory video, I totally forgot to mention and link to this particular announcement video, Machine Learning in JavaScript from the TensorFlow Dev Summit, where Nikhil Thorat and Daniel Smilkoff, the creators of TensorFlow.js, talk about the project. And you should watch that because it'll give you a lot more background, and also they'll show interesting demos and other things that people are working on with it. Okay, so I wanted to mention that. Now, okay, so if you didn't watch my previous video, which is kind of an overview of the landscape of all of the pieces around working with machine learning in JavaScript, you could go watch that, or you could just be right here. Because what I'm going to do in this video is I'm just going to go to this API reference. And in this API reference, what I want to do is talk about the basic building blocks of TensorFlow.js. Now here's the thing. Again, I just want to mention that you don't have to be here right now. You could go do movies anywhere else in the world than watching this video. Ultimately, I'm going to start using something called the Layers API, which is built on top of, which is part of TensorFlow.js. So there's core TensorFlow.js. Ultimately, for projects that I'm going to make, I'm going to use the Layers API, which is a higher level abstraction. And then even higher, I'm going inverse, like down is higher level. Eventually, I'm also going to use something called ML5, which is a project being developed here at New York University, which is a JavaScript library, separate project from TensorFlow.js, but uses TensorFlow.js behind the scenes to show demonstrations of common machine learning tasks like image classification, poetry generation, and things like that. Okay, so, but for me, for my own sanity, I would like to learn the basics of the core API of TensorFlow.js, and I think it's useful as foundational knowledge for moving along and looking at some of this other stuff. But if you just want to get to like getting your webcam and trying to classify the images that are in your webcam, you could find some videos that aren't made yet, but they will be made, maybe, I don't know. Oh, this is very confusing. I'm going to make some with ML5. We'll be getting to that. Okay, so core API. What is the core building block of everything in TensorFlow? It is something called a tensor. And I talked about this in the previous video, but just to recap, we have this idea of a scalar, which is a single number. We have this idea of a vector, which is a one-dimensional list of numbers. And we have this idea of a matrix, which is really a two-dimensional grid of numbers. A tensor is a sort of more generic term that refers to any n-dimensional thing of numbers, and also the operations associated with those things like matrix multiplication. And so this idea of a tensor being this building block, it's a thing you can make and perform the common mathematical operations. It's actually quite similar to in P5. If you watch my P5.js tutorials, I use this create vector function. So this create vector function is making a vector, and actually a 2 or 3 dimensional vector. So it's always just like an x, y, I meant to write. It's always just an x, a y, and sometimes a z. And so then you can make these create vectors and you can get their magnitudes and normalize them to common mathematical operations. The tensor is exactly the same thing. So if we now go and look at the API here, we can see here it is, TF tensor. So how do we even make a tensor? Let's just make a tensor. So first of all, I have some code. No, very little code. I have a single file called sketch.javascript. And you would think like, okay, let me just go and take this, and let me just put it in here. I'm going to hit save, then I'm going to go back to the browser, I'm going to hit refresh, and uncaught reference error. TF is not defined. So why is TF not defined? Well, it's not defined because I need to import the TensorFlow.js library. So a way that I can do that, I'm actually just going to Google, I'm sure it's like in an obvious place, but TensorFlow.js CDN. And then, oh, it's actually right here on the home page, right here. This is what I'm looking for. I'm going to grab this bit of code right here, because what I want to do is reference the TensorFlow.js library file via a CDN. A CDN is a content delivery network. I could download the library, include the TensorFlow.js JavaScript file in my project, but it's a little easier for me right now just to go into index.html. You can see I'm actually referencing P5 and P5 DOM libraries as CDNs. I don't know that I'm actually going to use the P5 library in this video, but I can just add one more here. And now I have TensorFlow.js imported as part of my project. And I'm going to go over here. I'm going to hit refresh. And look at that. Ha-ha! It's our first tensor. We made a tensor. We made a tensor. OK, so I've made my first tensor. Now, one of the things that you'll notice if I go to the TensorFlow documentation, whoops, is that in addition to just tf.tensor, and there's also, by the way, look at this. I need to talk about shape and data type. But just for a moment, I want to just show you, there also is this, tf scalar. We want to talk about that. tf tensor 1D, 2D. OK, so here's the thing. This idea of a tensor, tf tensor, is a generic concept that will work for any n-dimensional tensor. But if you're working with TensorFlow.js, you want to, the extent possible, use the functions that specify something about the shape. So what do I mean by shape? Oh boy. So here's a really important concept, a shape. The shape refers to the dimensions of the tensor. So for example, this right here, this has a shape that's 2 by 2. I could write this. This now has a shape. I think it's 2 by 3, because you always say the rows first with matrix. This is 2 rows by 3 columns, 2 by 3. So one thing that's important when creating tensors is to also specify the shape. Like, why does this even matter? Whoa, we're just kind of in the low-level land here, just to get a sense of how these things are. The reason why this matters, for example, imagine if what I'm ultimately going to do is feed in image data into a neural network for some task like image classification. Well, I want, and what I have are lots of images. Maybe all those images are 28 by 28 pixels. So my shape is going to be 28, 28. And let's say that I actually have 100 of them. I have 100 28 by 28 images. This is exactly what I'm going to have for the doodle classifier example that I'll make at some point. Then the shape of all of the data is 100, 28, 28. Because I have 28 by 28 images and I have 100 of them. So this is a really sort of important piece. This idea of the shape is a really important piece of defining a tensor. So let's take a look at that real quick. So let's come back and let's go back to here, and let's just do this in the console. So I'm going to say, by the way, one thing I didn't, I guess I could keep doing this in my code. Let's keep doing it in my code so I have a record of it. So one thing I didn't mention, by the way, is why am I saying tf.tensor? And first of all, I'm going to write this in a different way. I'm going to say constant nums. Let me call it data. Data equals, let's write this out like this, and then data.print. So let's look at this. So one thing that's a key here, that I'm using the way of declaring a variable called const for constant, which means I can't reassign this object. And so this is what you're going to commonly see in the TensorFlow tutorials. I could say let data, but in a sense I'm using const because I'm protecting myself from reassigning the variable data to something else later. So I'm going to say const data, then data.print. We'll go back here, and we'll see there's the tensor. Now incidentally, what if I say console.log data? So the tensor, that print function is a helper function in there to let you sort of see just the information, the data that's in the tensor. But if I actually say console.log data, what you're actually going to see is, oh, look at this whole thing. So a tensor itself is actually this complex object. So this is useful for us to be able to see the sort of properties of it, but most of the time we just want to look at the data. So another thing that I can do here is I can say console.log data to string. So data.print just takes the string version of the tensor and puts it into the console. So if I do this, hit refresh, we can see there's that tensor as well. Okay, now here's the thing. What if what I want to do is these are pixel values. Oh, let's actually say these are pixel values, like 0, 0, 127, 255. And what I want is for these pixel values to be a 2 by 2 image, to represent a 2 by 2 image. So I want to create the tensor with a 2 by 2 shape. So now let's look at what we see in the console now that I've defined a shape. Look at that. We can see that it's basically a two-dimensional array. And what I could do is, what's interesting about this, let's say I had 2 of these images. So now there's 8 values, and we'll make these like totally different numbers. Now, what would happen if I try to turn 8 numbers into a 2 by 2 tensor, a 2 by 2 tensor? Look at this. I'm getting an error. So this, by the way, this is an error you're probably going to see throughout your life if you go down this road. Now, not exactly this error, but constructing tensor of shape 4 should match the length of values 8. So this means like, hey, you gave me 8 values, but you're trying to make a tensor that only has 4 values. I can't do that. And this is actually quite a common error. I was trying to work on a doodle classifier with TensorFlow.js earlier this week, and I kept getting all these errors because I was trying to train my data set what didn't match the size of what the machine learning model expected. So we're getting a little baby steps into that, this idea of if I'm preparing data as if I'm loading it from a file, a spreadsheet, and I have a big list of numbers, I better have the right amount of numbers to put it in the right size tensor. And so this can now be corrected in the code because I can say, well, actually what I want, and it's awkward that all these numbers are just 2, but hopefully you're following me here, is I want to have 2 by 2, and I want 2 of them. So now, if I add, the shape is really, and let's, well, I'm going to leave it as an exercise to you. Try to redo this, but use like a 3 by 5. And so now, and I'm going to do that myself. I'm going to hit refresh, and you can see, there we go. There's my, essentially, this is the shape now. It's 2 by 2 by 2. Okay, so let's do a couple more things here. Let's say console.log data, just so I can see now. So what I have here is, that's the sort of pretty version of the data. There it is. Those are all my numbers now shaped into these arrays. Now also here, look at this. I can see that the shape is 2 by 2 by 2. The size is 8, meaning there's 8 total numbers. The type, this is something I haven't talked about. Type is important. I'm putting floating point numbers in there. So that's the default type. For example, this could be 127.5. And if I run this again, we're going to see 127.5 is in there. However, I could have changed the type to, if we go look at the documentation, int 32. So for example, I could say, you know what, I want to be more, I don't need to have floating point numbers. So I could change the data type to int 32. And that's just one more argument for me to add here. Int 32. Now let me run this again. And you can see it actually worked fine. It didn't complain that I tried to give it a floating point number, but it just took off the decimal place. And my assumption here is it's not going to round it. Like if I make this 127.999, we're still going to see 127 there. It's always going to floor that value, meaning take off the decimal place. So we can see now, in making a tensor, we have 3 important properties, essentially. We have the values. These are the numbers that are going to go in the tensor. We have the shape, which is defining the dimensionality of the arrays of data, basically. And then we also have D type, or data type, which is saying what goes in that tensor. And the only possibilities are floats, ints, or booleans. So you can imagine just like if you know you only need integers, you're going to save some memory or some GPU-ness by using integers instead of floats. So this is what it means to make a tensor. So I want to do 2 more things before I move on to the next video where we'll start to look at some operations, or mathematical operations on these tensors. And also I need to talk about the difference between a tensor and a variable. I'll get to all that. So let's do a couple more things. Number 1 is let's do something a little more interesting. Let's make a tensor that is 5 rows by 3 columns. 5 by 3. So I need 15 numbers. So let's make an array. Well, I'm gonna be a human who uses the const now. Values is an array, and I'm gonna just say I equals 0, I is less than 15, I plus plus. I'm gonna make up some pretend data, and I'm gonna use p5 random function. I could say math.random if I wasn't using p5, between 0 and 100. And then what I want to do is, and then I'm gonna make a shape. And I'm going to say the shape is 5 by 3. Then I'm going to say const data equals tf tensor with the values and the shape. So this is perhaps a bit more like how you might want to do it, right? For example, this is me loading in a lot of data from a spreadsheet or from another API, or loading image files and converting them to pixels. There's actually a from pixels function in TensorFlow.js that'll just take pixel data and turn it into a tensor. But so basically, so I have 15 numbers, I set the shape, and now I have this tensor, and now we're going to look at it down here. Let's take a look and see if this worked. So now we can see, now this is a little bit awkward to look at because of all, there we go. Look at this. It is 5 by 3. 5 rows, 3 columns. So this is working, this is good. Now, what happens if I were to have 30 numbers? I get that error. But again, this could be 2 by 5 by 3. And now you can see I have 2 chunks of 5 by 3 data. So now at least we're able to see how this kind of shape stuff works. And if I wanted to, I could also add back in int 32, because maybe what I want are just integers, and you can see it looks a little nicer there. Now, here's the thing. All this time, I have been using just the generic tensor, tf.tensor. But if we look at the API, and this is the last thing that I wanted to point out here, if we look at the API, what you'll actually see is, first of all, it's scalar. So this is rank 0, meaning a single number, rank 0. There's an idea of a ranking here. TensorFlow.1d is rank 1. That means a vector. TF Tensor.2d is a matrix. That means a matrix. And 3D. So even though you can just use tf.tensor, it's going to make your code more readable, and you're going to protect yourself from more errors if you use in here the actual, if you actually specify the rank that you intend. So for example, if I just go back to the console for a second and I hit clear, I could say scalar 4. So this now num.print is just a tensor with a single number. That's scalar. Now again, I could have said num t equals tf tensor 4. And then I could say num.t.print. This is exactly the same, right? tf tensor4 or tf scalar, but I have possibly more legible, readable code by saying tf.scalar. So now, if I go back and look here, even though I'm also just using the generic tf.tensor, this is really a rank 3 tensor, a 3-dimensional tensor. So to make my code more readable, what I want to do is, and also to protect myself from errors, what I want to do is come here and use tf.tensor3d. So again, if I know I'm just making a 1-dimensional vector, I'm going to want to use tensor.1d. If I'm just making a single number, tf.scalar 1d. So I'm just going to change that here, tf.tensor3d. I am now going to go back to the sketch. I'm going to hit refresh, and we can see there it is. Here is my tensor, which is 2 by 5 by 3. Okay, so I think this concludes this particular video tutorial, where all I have done is show you what is a tensor, how do I make a tensor, what is shape, and what is data type. Now that I have this building block finished, in the next video, I need to actually talk about something. These tensors are known as spooky music, immutable, spooky, whatever, I'm not going to bother with spooky music. They're immutable. I cannot change the values. So there is something called tf.variable, and the distinction between tf.tensor and tf.variable is important. And I want to look at reshaping tensors, as well as I want to look at the operations. So what does it mean to multiply tensors, add stuff to tensors, square tensors? What are the kinds of operations, mathematical operations? Just like there are a whole bunch of mathematical operations with a P5 vector, what are some of the mathematical operations with a TensorFlow.js tensor? Okay, so that's what will be coming in the next couple videos.